molybdenum, comparable to steel, melting point of 2,000 Fahrenheit, higher than iron. Sintered materials is certain material that cannot be alloyed by melting, can be useful products by mixing powdered form, compressing under high pressure, bonding by sistering. Metals for high temperature service contains over 50% iron with addition of 10 to 305 chromium and varying amounts of copper, nickel, tungsten, and silicon. And second, it contains up to 25% of iron, 50 to 60% nickel and chromium, and small addition of manganese, tungsten, silicon, and molybdenum. Contains 0.5 to 6% iron as an impurity over 80% nickel, considerable chromium, and small amount of manganese and silicon. Refractory materials. Materials with melting point above approximately 2,550 Fahrenheit and kadalasan siyang ginagamit sa gas turbine, rocket, glass making, and electronics. Ceramics. Materials of a high percentage of alumina and thermal and electrical resistivity, insulators, bearing, valve seats and pistons, chemical containers, and IC turbine. Natural and synthetic rubber. Raw rubber is pure state used in rubber cement and surgical tape. Hard rubber, electrical insulation, switch handle bearing. Yung hard rubber is kadalasan natin siya makikita dun sa mga extension wire natin. Yung handle which is gawa siya sa hard rubber. And semi-hard rubber. Rubber belting, flexible tubing, hose, springs, vibration control, or damper. Ito is makikita natin siya sa mga wire. And yung vibration damper na kadalasan makikita natin sa mga motorcycle. Synthetic rubber. Neoprene and Buna rubber. Plastic. There are two types of plastic. One is thermoplastic. It is softened under heat. Reharden when heat is removed. Thermosetting. Harden under heat until the heat has no softening effect.
In order to better understand and describe materials, there will be 6 keywords to help you guide with it. These are stiff, strong, ductile, brittle, tough, and hard. This could help you better understand and able to know why such specific materials are used for their specific purposes. More of this in the latter part of the presentation. Next. Tensile test. Tensile test is a basic idea of a tensile test is to place a sample of a material between two fixtures called grips, which clamp the material. Tensile test is said to be fundamental materials in mechanics. It is performed by pulling a material or sample in which it will grip at yung isa is fixed. Naka-fix yung sa taas tapos hihilahin lang pababa in order to find the force and displacement on how much pull or force it can handle. It gives us the stress strain that you can see in the next slide. This is the stress strain curve. To give you an idea with it, next. Stress is a physical quantity that expresses the internal forces that neighboring particles of a continuous material exert on each other. As we all know, stress is denoted by Greek letter sigma, which is nandito sa ating slide, and it is denoted by force or force over cross-sectional area, which gives us Newton over meter squared or yung ating pascals. It basically means that it is the force applied to the cross-sectional area. And ito, makita, ito yung na-introduce na natin dati, yung within the past years sa ating mga past courses o yung ating mga past subjects na na-take na natin. Next is strain. Strain is the measure of deformation of the materials, and it is not a physical quantity. Kung makita nyo sa ating picture, yung sa ating stress strain diagram, yung nasa y-axis natin is yung stress and nasa x-axis natin is strain. To put it simple, ito yung deformation na nangyari sa material natin after we put force onto it. And it is illustrated by length, change in length over the original length. O yung pag sinabi natin kasing change in length, yun yung ating elongation na sinasabi. In the stress strain diagram, we could see that we could raise the stress onto materials. At nagsisimula pa lang siya mag-deform. Kung makita natin dito sa let's annotate. Pabak. Yan. Kung makita natin dito sa graph na ito, wait lang. Dito sa graph na ito, pag nagdadagdag tayo ng stress, na lumalaki din yung ating strain. At sa pagsisimula niyang pagtaas ng stress, nagsisimula na rin siya mag-deform. And the first region na tinatawag natin nandito sa point na ito is what we call yield strength. Next. Pag sinabi naman natin yield strength, it refers to an indication of the maximum stress that can be developed in a material without causing plastic deformation. Ito yung masasabi nating allowable stress, yung parang kapag yung force na pinut natin at nandun siya sa yield strength, then inalis natin yung force, babalik siya to its original shape with minimal deformation or no deformation at all. At kung sumobra na sa point ito na yung nagkokos ng permanent deformation. Pero dahil makulit tayo, dagdagan natin ng stress. Joke lang. Di ba kaya nga natin dinadagdagan ng stress is para kasi yun yung purpose ng ating tensile test. Pakibalik doon sa ating graph. Ito yon. Ito yung yield strength nating sinasabi kanina. And sabi ko, kapag lumampas na siya dito siya nagkakaroon na ng permanent deformation. At kapag nandun na siya sa pinakang peak o yung ating plastic deformation, kung patuloy na tayo nag-add ng stress, it will eventually hit dito sa ating ultimate strength. Next. Isa pa. Yan, ultimate tensile strength or UTS. It is the maximum stress that a material can withstand while being stretched or pulled. To put it simple, this point is where the material dito, yung material natin is, yun na yung kaya niyang stress na i-handle. Na kapag sumobra na dito, doon na eventually aabot na tayo sa ating fracture. Pero before mangyari si fracture, nangyari muna dito yung tinatawag nating necking. Kung makikita nyo dito, na 'di ba may sinabi nga kanina sa presentation namin na kapag inipull yung isang material, unang-unang nagkakameron ng deformation is yung sa gitna, which is dito. Ang tawag dun is necking. And by definition, necking is, next. Necking is a type of plastic deformation observed by in ductile materials subjected to tensile stress. Dahil siya nga ay necking, nagkakameron siya ng ng V or neck shape. Pabalik dun sa slide. Nagkakameron siya ng V. Parang masasabi nga nating may neck na siya dito kasi doon na nagsisimula yung yung parang fracture na pag-add natin ng stress dito. During necking, a large amount of local strain is concentrated in a small region of material. Therefore, necking is often closely associated in yielding. And as we continue sa pag-aano natin na pagdadagdag ng stress na eventually it will put into fracture. Next. Dito. Aabot na siya into fracture na yun nga, magkaka-fracture na kasi yung ultimate strength nga yung sinasabi nating peak, and kapag dinagdagan pa natin ng load or yun nga ng load is dadagdag din yung strain. Yeah, eventually hindi na kinakaya ng ating material, nagpa-fracture na, nasisira na. Next. In this stress strain graph, we could use lot of information about the material used in the tensile test, and there's this Young's modulus. Young's modulus is a numerical constant named for the 18th century physician and physicist Thomas Young. Ito yung sinabi ni Thomas Young. Next. Yung tinatawag nating Young's modulus. Young's modulus is a property of a material that tells how easily it can stretch and deform, and is defined as a ratio of tensile stress to the tensile strain. Basically, yun lang is stress over strain. And Young's modulus is said to be one of the most used properties in engineering, as it can be used to determine the deflections ng isang material sa iba't ibang mga scenarios. Also, yung mga engineers din, which is we would be eventually, engineers are using the yield strength and the ultimate tensile strength in order to determine the maximum allowable stress ng ating mga material. Next. Yan. Konting trivia lang tayo. 'Di ba nabanggit na din kanina yung mga mga definition ng mga ductile and brittleness. Bibigyan ko lang kayo ng kaunti pang background dito. Opposite ng ductile is itong tinatawag nating brittleness. And ibig sabihin lang nito is yung ating material will break with a little deformation. Konting deform lang, sira na agad, kagaya ng mga glass, ng mga konting na konti mong ginanto, sisira na agad siya. Magkakamera na nagpa-fracture na agad. Materials may be ductile or brittle depending on their temperatures. At yun yung sinasabi na dahil rin daw sa brittleness ng ating Titanic, yung Titanic na boat or yung ating ship is bukod sa 'di ba bumangga nga ito sa ating isang iceberg. Kaya din ito nag-fracture dahil hindi daw nito kinaya yung low temperature ng dagat. Kaya naging brittle yung ating material and nasira din, madali siya agad nasira. Thank you.